All right, welcome everybody to the Golden Gate and the Garden State chapter of the ASPE meeting. We have two distinguished guests this evening, Sam Andreas with principal for 2WR Architectural Group, and Art Hance, master builder out of Washington, New Jersey. And they're going to speak tonight about the medical marijuana and recreational marijuana industry and how it's progressing and what it's all about, and give us some more insight on how to grow it and where they're how they're developing the industry and whatnot. So without further ado, I'd like to turn it over to who would like to go first, Art or Sam? Do you guys have a preference, or?
We're kind of a tag team, so right. we have a video, some slides tonight, and Sam and I are going to break it up as we go through. And
am I good to share my screen, guys?
You're good.
All right.
Yes, it is.
All right, Art. Thank you guys for having us this evening. We're going to kind of talk about cannabis tonight and talk a little bit about facilities, the cultivation methodologies, what goes into a facility, site selection, how it's selected, and then cost of building facilities out. So Art will kind of kick this off with a little bit of discussion about site selection.
Okay. Many people are looking to get into this new business. We're seeing a lot of activity right now here in New Jersey with the recently passed legislation. The reality is siting a cannabis facility takes a great deal of upfront work. The requirements for a cannabis facility are very different than most buildings you will estimate and build. The first big issue that we run across with a cannabis facility is power. If you have a 50 or 60,000 square foot cannabis facility, you will consume somewhere in the neighborhood of the power equivalent of 4,000 homes. We'll talk a little bit more as we go through the evening about, certainly the grow lights and everything, but the other things that use power. Excuse me. We find that many of the sites that are situated where you can actually grow cannabis without local opposition do not have the power infrastructure needed to run these facilities. So we have to start to look for other forms of power to power everything in the grow facility. Typically, the next thing that we'll turn to is natural gas to power chillers. Instead of powering them with electric motors, we use internal combustion engines that run on natural gas. The natural gas companies will be thrilled to hear from you if you're going to go in that direction, and they will probably add infrastructure where typically the electric companies are going to make you pay for that infrastructure. We have a project right now that Sam and I are working on that required considerable amount for full build out. We did an initial power upgrade that cost us in the neighborhood of $250,000. They got one phase of the operation going on a limited basis. For us to build out the whole facility, we figured that the fees that we would incur and all the work that would have to go into it would cost $8 to $10 million. We can build quite a cogeneration plant for that money. And that brings me to the next thing, which is CHP, combined heat and power, or cogeneration, where similar to gas-fired chillers, you would have gas-fired generators that run continuously. We also harvest heat and CO2 for plant injection from those generators. And it makes a very, very efficient system to install. There are companies out there that will build these plants and lease them back to you. You don't get quite the savings long-term that you would get by building your own plant. Once we've got you powered up and going, you've got to think about water. The plants need to be watered. You have clean down water. You have other uses of water in the facility. Typically, a local water source, a water company is not going to want to supply that amount of water. Sam can tell you, he'll go into a little bit more about the water consumption. So then you start to look at the use of wells to supplement what you may be getting locally. Once you have captured that water, realize that a lot of that water comes back as condensate. About 90% of the water that goes into a room is transpired by the plants to cool themselves during their growth cycle under the lights. That water comes out of the room as condensate. Typically it's recycled and may be run through an RO system and then re-injected back into the fertigation process. Finally, whatever water is left over has to be disposed of. And most towns will not let you do that to groundwater. Although the nutrients and everything used, particularly on the medicinal side, are pretty benign, they're not going to want you dumping this into their sewer system. So you have to look at disposal techniques, avoiding groundwater disposal or local system disposal. If you have a 50 to 70,000 square foot facility, conservatively, you're going to have probably 30 or 40 people per shift at a minimum working in the facility. You need to get those people in and out. If you are running multiple shifts, that means that you're going to have that overlap period where people are coming and going. So you have to look at the impact of traffic and access control for the site. Probably the biggest issue that people have faced from a complaint standpoint on cannabis facilities is the odor. There's a road that leads from the Denver airport to the city called the Green Mile, and you can smell cannabis very strongly there. You can pretty much smell it when you land. And if you've never smelled a cannabis grow facility, it's kind of like getting a herd of skunks pissed off. It'll create quite an odor, and your neighbors will not be happy. We touched on local opposition before, and I have to stress that that can be one of the biggest hurdles that you will face in building a cannabis facility. We have a project where there's an OPRA request on every Monday to see what we have submitted to the building department the previous week. We've had several lawsuits to stop construction. And if you are estimating a project, you're a contractor working on a project, you constantly have that hanging over your head. Your general condition costs are going to go on whether there's a stop work order or not. So these are all things that you have to pay attention to. Often we get the question of which is better, a existing facility or a greenfield where you're building from the ground up. We find that the costs probably average out to be similar. It typically is a little bit more expensive. It can be a lot more expensive to build in an existing structure, and your efficiency is typically not as good because you are limited in your layout. But you do have infrastructure there. There's often parking. There may be sanitary sewer, water, electric, other things that are coming to the site. So you're not incurring the site development costs that you would otherwise. If you're greenfield and you're coming up out of the ground, you can get very efficient. And as cannabis becomes more popular, it will be commoditized, and the people that can generate a product more efficiently than others will be the ones that are successful. I think that's about it. Sam, why don't you go through and talk a little bit about the different facilities?
All right. I appreciate it, Doug. So basically there's three different types of cannabis facilities: are cultivation and processing. Processing being what happens with the plant directly after cultivation. Then there's manufacturing, where you're extracting and infusing products. And then there's dispensaries. And facilities can be standalone, any one of those three, or they can be a combination. And when there's two or more of those combined into a building, they call it a vertically integrated. So it could be cultivation processing in a dispensary, or cultivation processing manufacturing, or it could be all three. So what we're going to do kind of this evening is look at a vertically integrated facility. We'll talk about the different spaces in it, and we'll talk about cultivation methodologies. And one of the things that you'll begin to see as we go through this is that there is no set, this is the best way to grow cannabis. In fact, one of the greatest challenges in the cannabis industry is that there are a wide variety of ways to grow, and not just in terms of mediums that you grow within, which we'll talk about, or lighting that you use, but everything becomes a grower's choice in how they grow. And we'll talk about all these different variables that come into play in the design of facilities and the cultivation of cannabis. And then as we get to the end and Art starts talking about the cost of building these out, how the different approaches impact the cost.
Sam, if I could add one thing, in New Jersey right now, you are allowed to have a vertically integrated license. You are not allowed to have a vertically integrated facility that includes dispensary. So all of your grow and processing, manufacturing can be in one facility, and then you have a separate facility for the dispensary.
Thank you, Art. So the facility that we're going to kind of use as our talk this evening basically is a 2-story, and it's got the cultivation initial processing on the 2nd floor, and then all of the processing operations and dispensary on the 1st floor. And basically in the cultivation, you have a mother room, a propagation, potting area, you have a veg room, and then you have flower rooms. And the flower rooms are where the plant buds, flowers, and the way the industry talks about it, that's where the money's made. Then once it's done with its cycle of growing, it's moved into a dry room. From the dry room, it moves down to actually the full processing. So when we talk about manufacturing, we have extraction, and then we have infusion. And infusion can be non-edible. So MIPS is medically infused products. So in manufacturing, you have non-edible, and in a MIPS kitchen, you have edibles. Then you have packaging areas. You've got trim, where they're trimming the flower and they're going to sell the actual flower. You have packaging for the flower. You have vaults. You have a cure room. We'll talk about that a little bit more. Like in any manufacturing, you're going to have shipping, receiving. When we talk about specifically in terms of cannabis or any type of cultivation indoor, you've got your fertigation, which is the nutrient delivery of your irrigation. RO, Art mentioned RO earlier, that's reverse osmosis. It's a water purification. You have your water storage. You have an operational component. You have your restrooms and locker rooms, so you have a clean environment. And then you have your dispensary component. So those are the parts of the puzzle. So when we talk about cultivation, that's kind of where we'll start in this facility. we can look at, and this begins to talk about some of those options. So in a cultivation room, the lighting itself could be fluorescent, CMH, ceramic metal halide, HPS, high pressure sodium, or LED. And again, a lot of this comes down to grower preference, what they like to grow under. There are conditions that dictate lighting. So when you have a environment where you have to have low heat, like multi-tiers, you're forced into LED. Beyond that, the selection's wide open. On irrigation, it can be drip systems. We'll talk about those, or pure hydroponic. Benching, a wide variety of options there. Single tier, roll top benches, multi-tier fixed, multi-tier mobile. The HVAC systems, that's one of the highest cost in the design of a facility. That can be a water source system like air-cooled chillers or gas-fired chillers. It can be DX, which is one of the more common, or it can be hybrid, where it's a DX with a backup of a water source system or a supplement. CO2 is utilized, and CO2 is distributed to help the plants in their growth process. What rooms the CO2 is used in comes down to grower preference. Other items that go into the grow room are kind of, they're like the options. So hose bibs, hand sinks, drains, some of those things come into play when you're thinking about whether you're doing a new facility or you're renovating an existing. It's hard to kind of put trench drains all over an existing building. So sometimes we're doing sumps and pumping the water above and draining that way. And then other things you have to think about in a cultivation room: door swing, slopes to the drains, reclamation systems, which Art also mentioned. When we talk about the process of growing, the way plants kind of move through a facility, everything begins with the mother room. That's why they call it the mother. Mothers are really the lifeblood of the facility. And then from a mother, you take your clones. The clones are about a 10-day process, and they move to propagation. The propagation is to a point of rooting. Then those are the rooted plant is now moved in vegetation, veg. And then from veg, they're moved into flower. And again, like everything else in cannabis, the timeline that plants are in veg, really mainly propagation and veg, are growers' preference. And we'll talk a little bit about that. Where here it says space sizing is all in the math. This is one of the things as an architect that, we've probably designed 80 to 90 facilities worldwide now. What we found is that, when we first got in the industry, people talk about growers mainly, that a veg room should be 25% of the flower and in your veg area, and that mothers should be 20% of the flower. The reality is that it all is mathematical formulas and ratios, that the number of weeks that plants are in veg impacts the size of the space. If you're 3 weeks, it can be smaller than 4 weeks because of the number of plants. So everything within a facility really ties together in terms of mathematical ratios.
Just as a side note, Sam and I have worked together for about 2 years now. We've been through the design and redesign and subsequent 2 more time redesign of various facilities. And growers will come in and tell you that they need a certain size drying area or grow rooms or whatever it is. We've sat down with them and done the math. And I believe that every time we've come up with different figures of what they need for these spaces. And it's extremely important to get that math down properly. The other thing to remember as an owner of a facility is that you have a grower right now that will affect that math in one way. The grower that's there now may not be there a year from now. And if you build your facility to that grower, you can be in a problem later on. So you really want to reach out to people like Sam, design teams that can take you through the process and give you a more flexible facility that can expand and contract as you need it to, both for business and for changes in grow methodology.
And Art, that's spot on. I think that, you know, as Art's saying that, I'm thinking about the project that we're working on together where they've actually gone through 3 different growers through the design process, and every grower that comes in has created their own changes to the design. And one of the things that, you know, you find as you begin to work in the industry is generally owners really don't understand cultivation, so they rely on a grower, and that grower's ideas or methodologies or way they want to grow may not align with the business's vision or the business plan. And so, you know, understanding how changes impact the overall flow, the function, the size of space, and even the revenue a company can generate is important to be able to talk to an owner about and really begin to explore other options if you feel like a grower is leading them down the wrong path. So here we're talking again about the mother plant, and we're going to go through and kind of talk about each of the spaces within building. That the mother is generally where all plants in the facility come from. There are other ways that a company can expand and grow, but 90% of the companies out there, businesses that are cultivating, grow for mothers. So you have, you know, a variety of different strains, and you have a large number of mothers, and they basically take a clone. And you see right in this image, they're taking a pair of scissors or cutting a little clone off of it, and then that clone goes into a container and basically starts a growing process. The number of clones that a grower takes from a mother goes back to grower preference. And, you know, basically the size of the mother, how long they give that mother to recover after they clone. So if they're using a mid-sized plant, they're taking 30 clones, they may only give that mom about 2 weeks to recover. If it's a mid-sized plant, they take 60 clones, they may have to give it 4 weeks to recover. So those kinds of things impact the number of moms you need and the size of space in the mother room. And then even into what the mother room is and how the mother room is set up, that becomes a grower preference as well. So the plan on the left is a project that's in Massachusetts. This plan, the grower wanted mother, clone, and his potting all in one room. The plan on the right, the individual wanted a mother room, a separate mother room from the prop room with planting in the propagation room. So those things become separated out, whereas here it's all in one. again, grower preference. That's just this is a picture of all your healthy moms, and these have not been cloned, and that little skimpy thing right back there has definitely been cloned. It's in its recovery mode. So after cloning, the clones basically are, they're in clone about 10 to 14 days, and basically to a point where they're rooting. And then at that point, plants can basically move from propagation into veg. And again, here we go with grower preference. What you see on the left is more of a $500 option for basically growing the clones, to a point of moving them to the veg. And then the easy clone machine, we can have about 750 clones in here for just about $8,000 for that machine. Veg, again, grower preference. So the time that a plant is in veg, we show here 2 to 8 weeks, basically is determined by the size of the plant that the grower wants in the flower room. So if they're doing smaller plants and more of them, it'll be a 2 to 3 week schedule. If they're going larger plants, less of them, bigger and more robust, it'll be more like 4 or 5 weeks. 2 and 8 are the extremes. 3 and 4 are the two that are most prevalent. These are just photos of different styles of veg. So on the left, fixed steer, dual level veg benching, and then on the right, those are mobile. Those benches roll from one side of the room to the other. They basically, these two show 2 different cultivation methodologies as well. On this side, it's more of a drip irrigation, whereas here it's a system called ebb and flow, and we'll talk a little about that. Flower.
And you might want to mention that the benching is designed so it can move and slide, so you can get between various benches and work on all the plants.
Correct, and we'll hit that in a couple of slides.
Okay.
Flowering is this is where the money's made. So in flower, we're generally somewhere between 7 and 9 weeks. It's strain specific to the exact amount of time to full maturity. 8 weeks is an average. And so when we're designing facilities, we like to build the number of rooms around that 8-week harvest schedule. So 4 rooms, 8, 12, 16, and it makes it easier to schedule everything that goes on within a facility. And these are just a few pictures of flower rooms. And this one is kind of cool because you can actually see by the color variation and the size of the plant that in this room, they're growing 3 different strains in one room. So there's a number of different styles of cultivation. This is called scrog. And what scrog is screen of green. And what that means is that they take the plant, they strip everything that's below this screen line right here. They strip it off the plant. And everything above the screen is where the flower will grow. So the idea in this approach is that all the nutrients and all the light are really feeding everything above the screen, and you're focused on only growing above the screen. This is another view of the scrog, and you can see how it's just this field of green above that screen and very stripped down below it. The other way is more of a sea of green. And so in sea of green, you can see in this image, the plant below the screen. So they basically are taking the plant and they're pulling it through the screen on the higher parts, but they allow flower to grow below that screen as well. So the scrog is much more labor intensive, but there are growers who believe they get better yields and better product out of a scrog than just a sea of green. So this is a sea of green as well. You can see the flowering and all the buds down below the screen line as well as above it. So then there's also a variety of mediums that plants can be grown in. We have soil that's, everybody knows about growing in soil. We have soilless mediums, and we have pure, true hydroponics. So when we talk about soilless, we have perlite, cocoa, and rock wool. Perlite can actually be mixed with soil, which is what we're showing down here. It can be used as a topping to soil, or you can purely grow in perlite. Cocoa comes in cubes, also comes in bags. It's very easy to grow in. The beauty of all three of these is that there is no nutrients within the actual medium. It's only the nutrients that you feed it through the fertigation system. And then rock wool is cubes. And so the plant basically is planted in these cubes. There are growers that utilize a mixture where they may take rock wool and they'll use that in the early stages of propagation. And then when they go to veg, they'll take that rock wool cube and plant it into cocoa and grow from the cocoa. The perlite, like I said, can be used as a topping for soil and basically help control the moisture content within the soil, and some of the other, like insect infiltration into the soil is controlled through perlite on top of the soil. So that picture on the upper left is where they're just using perlite over the soil. Hydroponics, this is where you're really talking about the roots that are basically given nutrients with direct contact with water with no soil or medium. Ebb and flow on the left is you can see we have this is clay pellets. The clay pellets just suspend the roots. These units on the left, the water comes into these units, the fertigation system, so the nutrients, they're pumped then into these pots. The water fills. It's in there for a set period of time, and then it drains back out and goes back to a holding reservoir. And then a little while later, they'll pump the water in again and drain it back out. And that process goes on throughout the lights on feeding period. Flood it, drain it, ebb and flow. Deep water culture, plants are suspended in a holding, like right here, you can see it in a holding mechanism, and the roots basically hang right down into the water. And the water is constantly, the nutrients, the fertigation is constantly flowing over those roots. And then the last is, on this page, is aeroponics. Aeroponics is like the vegetable area in your grocery store where you have the mist spray system that sprays onto the vegetables. That mist spray system is within these little vats right here, and it sprays directly onto the roots. So it delivers a mist of moisture onto those roots, and it does it at intervals throughout the day to deliver the nutrients. And then the last is aquaponics. And aquaponics is basically you've got fish, and the fertilizer, the nutrients that are delivered to the plant, is basically produced by the fish. Um, the reality of the different methodologies, so utilizing soil or a soilless medium where you're utilizing drip irrigation, those systems are much safer than utilizing a true hydroponic. And the reason being that when you're utilizing hydroponics, your water is basically, and I'm going to back up here a second, it's basically touching every single root within a row or within, a vat. So in ebb and flow, it's filling, it's draining, it's going back to a storage tank, it fills, drains again. And that water is shared through this entire room. If there's a root-borne disease, that disease will spread rapidly throughout the room. The same with deep water culture and aeroponics. And in aquaponics, the challenge is now you got to keep fish alive and your plants alive. The reality is it becomes a question of risk reward. Plants thrive and grow much healthier in a hydroponic based system. They grow faster, they're stronger, but the risk it becomes is a company willing to take that risk in their performance of how they're doing business.
Sam, you might add that the nutrients that the fish produce is not Miracle Grow.
Good point, Art. So Art talked about benching. There's a number of different types of benching that can be utilized. What you see on the left side, roll top benches. On the picture at the bottom, you can see it doesn't look like there's much of an aisle. The bench itself, you can see in this image how it's offset to the left side. A rolling bench will actually roll one way or another about a third of the overall width of the bench. So in this room, you could come in, you could walk down this side, come back, roll that bench over, and then walk down the other side. In this picture, they can roll benches, up the page or down it and create aisles anywhere they want to be able to access. Multi-tiered fixed benching, people still utilize fixed benching. It's a pretty cost-effective way to bench. Just doesn't give you much bang for your buck on space. And then on the right-hand side, we have multi-tier mobile benching. So these benches roll, they'll roll fully across the room. This system is much like the old library book shelving system where you could mobily move that book shelving across the room. We're going to talk a little bit about what we did about lighting. And one of the things that it becomes very prevalent in both in terms of how you cultivate, kind of drives direction for growers in terms of plant is lighting selection. So if a grower is using, say, HPS lighting, high pressure sodium, that light gives off a lot of heat. And what will happen is growers then they grow a taller plant. The light spectrum will penetrate much deeper into the canopy of the plant than an LED light. And so they can grow a taller, more robust plant than if you're growing under LED. So under HPS, a grower may choose to do sea of green versus screen of green because they know that that light's going to transfer and penetrate all the way into the deeper parts of the canopy. If they go to an LED light, they may be forced to look at a scrog, the screen of green, where they're cleaning everything out below because they know that light's not going to go as deep into the canopy. The other thing that drives growers to LED is multi-tiered options, and multi-tiered in flower. You have got to go to LED lighting because the HPS would burn the plants.
You find that a lot too in existing facilities that are being converted because they don't have the height, the ceiling to floor height, and they're forced to go to LED to keep from burning.
So then after basically you've grown the plant, you've grown your flower, and you're moving into the stage where you're going to harvest. And what they do with the plant at harvest, again, comes down to a grower preference, how things are done. So if you're going to hang your plants and dry them, you're going to take the plant and you're going to do what's called hucking. You're going to get rid of the main stalk and you're going to huck it down to just limbs and hang the limbs. They could hang the whole plant, or they could do what's called bucking. And bucking is basically like this machine up here. They're wet bucking, and they're going to buck it down to just flour, and then they're going to dry that flour on screens. And this machine up here, this little munch machine, that's called a mother bucker. So in dry again, they can, the dry rooms, dry process is about 10 to 14 days. How they dry is personal preference. Flash freezing is also an alternative to drying. So if they're trying to do more live resins, things like that, they may flash freeze. But again, they can hang the whole plant, they can hang limbs, or they can hang, or they can put the flour in baskets or tray and just dry that. So this is kind of different views of different kinds of drying systems. So plant or limb hanging, this is a custom-made racking system. It uses a unistrut-based approach, and these are mobile. They move backwards, forwards. They stack them, walk down the center aisle, build it, and fill it to dry. This is more of fixed shelving. They're just using hangers here, hanging off of the shelving. Similar approach here and here. And then on the right-hand side, it's basically your flower tray. So this has been bucked all the way down. These plants where they're drying, hanging, they're going to hand buck it down to the flower. And, that'll be after the dry process. So once the plants come out of dry, now they're ready for trim. This is where they're going to groom the flower and make it, a more appealing looking bud. It also, the trimming process gets these loose leaves that are all around the flower off of it and makes it, when somebody smokes it, it's less harsh without these little leaves that are on that flower. Trimming can be done wet or dry. Most people will dry the flower first and then do the trim. There's two different ways to accomplish trimming. One is by hand and one is by machine. These on the left, these are called tumblers. Tumblers are much better utilized for wet trim. They're more aggressive on the flower, And if utilizing a dry flower in a tumbler, you'll knock terpenes off of the flower, and you reduce the quality of the flower. On the right, you've got, these are called upright trimmers. And these upright trimmers are much more gentle the way the blades are set up to do the trimming. And this is a view of a trim room. This is where they're actually hand bucking, taking the flower, separating from the stock. The stock goes in the garbage can, flower goes into a bin. And then down the road, they'll separate the size of the flower, by basically separate the flower out by size of what they call the nuggets, the buds. So packaging of flower, they can do it by hand. Basically, you see here the scale. They're weighing it out, putting it in a container for sale. Or it can be machine, or it can be kind of a combination of both. So here we're separating the nuggets by size. This machine on the right, these two, they actually sort the flower by weight, and the machine then determines what goes into the packaging based on the weight of the flower. Over here, we're doing all of that manually on the upper left. All of that weighing and filling in the packaging is done by hand. We talked about a cure room. Curing is like fine wine. You take your wine and you put it in the cellar and you let it age. Cannabis is much the same. So if a grower wants to cure, and again, it comes down to grower preference. The process is basically taking that flower, putting it in containers, and slowly, methodically over a period of time, again determined by that grower, allowing the humidity to be released from bags or bins or whatever it is. The process of releasing that humidity is called burping. So the flower in a cure process is sealed and then opened, and that opening called burping, and then resealed. And it basically is just that curing process is a time, a time process of trying to make that flower even a more sellable and better product. And this is another view of a room where they're, much smaller than this curing process. And so they come in and open every one of these jars on a daily basis and burp them. Then extraction. So we've talked about the flower and the sale of flower and the selling of flower, packaging. Now we're going to talk a little bit about extraction. So extraction, you can extract from flower or trim. The majority of extraction is done from trim. So when they're trimming, they basically take that trim, they store it, and then they'll bring it in and utilize it for the extraction. There are a number of different ways to extract. The four that we'll talk about here are CO2, ethanol, butane, and keef. The thing to recognize with extraction is they go from non-volatile to volatile. Volatile meaning that it's basically fire hazard, an explosion. If you remember, probably 4 months ago, there was a big explosion in California in a butane storage facility. Butane is highly volatile. It was not ventilated properly, and it created an explosion. So the most volatile extraction is butane, second most volatile is ethanol. It's really based on the amount of volume of ethanol. And then CO2 and keef, neither one of those are volatile, non-volatile, both of them. So volatility characterized by or subject to rapid or unexpected change. Anything that is a volatile, ethanol or keef, ethanol based on volume, has to be in a class 1 division 1 or class 1 division 2, depending on how it'll be utilized. So these rooms, they have to be UL rated or UL listed. And I think Art and I can both talk about the difficulties dealing with projects where manufacturers say they're providing something that's UL labeled, but it's not.
That's been a big problem. A lot of people claim to have compliant equipment, and when it gets there, it is not. Make sure you get a UL listing before you order.
So here we see this is oil that has gone through the extraction process. In the background here, you can see this is this little machine right here. That's called a roto evaporator. This is an ethanol extraction unit over here. You've got a pump that forces the ethanol into an extraction vat, and then you collect the oil. Basically, that oil goes into a rotovate. The oil is basically a mixture of ethanol and cannabis oil. And then the roto evaporator, it's heated. The ethanol is recaptured for reuse, and the oil is what would remain. This equipment in the very back of the picture, that's called a vacuum oven. In a vacuum oven, basically you can take the oil once you go through that roto evaporator, put it on a tray, and you'll evaporate off the oil, and you'll be left with a product that looks like what's here on the left, which is called shatter. So that's another picture of shatter that comes out of the vacuum oven. And then this is batter or wax that is being pulled out of a butane extractor. This is just another photo of them basically in a vacuum oven creating the shatter. So the nutrient delivery, we talked about fertigation. Art mentioned the RO, reverse osmosis. That's right here on the right. This is an RO system. These are water storage tanks. The 3 smaller ones are nutrient tanks. The 2 larger ones are storage water. And generally, a facility in design, they'll want to store at least 1 or 2 days worth of water. So if there's ever a shutdown of water or there's a problem with the water source, they have at least 1 or 2 days backup supply. The water is moved from those storage tanks into these nutrient tanks or batch tanks. They'll mix the nutrients in these tanks, and then that goes to the fertigation system. This is actually the setup that when we looked at the ebb and flow, these tanks are providing all of those pumps to fill and drain those pots in the ebb and flow system. Here we have another RO right here, and the water storage and batch tanks. And then this is another one, the RO on the far side. This is a nutrient tank. And then this is part of the fertigation system. And then lastly, this is called a dosatron system. So here in this system, we're batch mixing and distributing. Here, we're mixing at the point of entry into the room. So in a dosatron system, you have the ability to deliver different nutrient mixes to every room. Whereas in a batch distribution, you're delivering the same nutrient mix to every single room. So what does all this cost? Art.
Okay, I put together some rough numbers based on projects that we've worked on. And what I did was a rough comparison. We just completed a 70,000 square foot, a 68,000 square foot trucking company facility, warehousing. It had 5,000 square feet of office and truckers lounge. And we took some numbers from that and compared them to a group of cannabis projects. Right off the bat, cannabis projects, when we talk about some of the complexity, take more field general conditions. Typically where you might just have a superintendent, you're going to need an assistant superintendent, additional project management capability. High-level demolition and site improvements, we know that those will be project specific. Concrete and masonry, typically we may have some additional concrete where we're storing water. We have a project right now, Bob Sebeli is working with me on, where we have a 48,000 pound water tank and we had to fatten a slab up there. But really the concrete cost for a warehousing facility with loading docks and everything like that is a higher concrete cost. You may be a little bit more in the area of steel. We have what we call goal posts throughout the facilities, often to support all of the piping that go into them. And I'll talk a little bit more about that in a minute. When you get into doors and windows, you're using very specialized doors. The openings to the flower rooms and the curing rooms, the drying rooms, these are all oversized doors, and they are typically what you would see in a refrigerated facility. They're insulated, they seal, and they're very specialized. The framing, typically you're mounting them in an insulated metal panel, so there's additional work to reinforce that opening. Here's where we start to see some other big differences. Security, 10 times the cost for the security in a cannabis facility. Someone in the chat room asked if you can get free samples. About the only thing that you can get out of a cannabis facility is the smell. And if you work or spend time in a cannabis facility, you will reek when you come home. But the security, there is not a square inch in the facility that is not under camera control. In New Jersey, those cameras are streamed live to the state of New Jersey and recorded. They're also available to local police department where the facility is located. So at any time, they can go on and see the streaming. And it is impossible. I wouldn't say it's impossible, but it is extremely unlikely that you're going to get out with any samples. Fire suppression may be a little bit more because of the number of rooms that you're breaking up. Plumbing is a big one. We have a facility right now where we have, I believe, 4 distinct waste systems in the building. We have our typical sanitary waste for employees. We have a trench drain system that captures all of the cleaning and runoff that gets past the air handlers. And then we have a complete system that just captures the condensate from all the air handlers to send it back to the RO system. And then there's a 4th system for areas such as mechanical rooms and things of that type. Electric, again, a huge expenditure in electric, 10 times the cost that you would normally see in a typical industrial building. The mechanical cost, though, is where we really see it skyrocketing. $100 a square foot is not out of the question at all for a cannabis facility. We have a 76,000 square foot facility right now. The mechanical package is $10 million. And, you know, to think about what's going on with these systems for a minute, you've got plants that are in a grow room. The lighting is on 12 hours a day and then switches off for 12 hours a day. While that lighting is on, the heat that's being pushed into those plants makes the plants transpire moisture to cool themselves. Again, 90% of that moisture is coming out into the air. And you would think that, I always did until I got involved in the industry, that you have a very tropical environment. The reality is that we see the humidities and the temperatures in the mid 70 degrees, 70% range. That'll vary by grower. So we're taking a lot of that moisture. I think Sam had mentioned about 90% of the moisture is transpired by the plants, and it has to be taken out with our air handlers. The problem is that we're using so much capacity to take that moisture out of the air that after a while we're going to start to push the air temperature down. So now we have to heat the coils, and there's so much that goes into it. These systems are operating for 12 hours, and then all of a sudden you shut the lights off. And instantly that plant is now in a very different process. It's not moving as much moisture, and the systems cannot react quickly enough. So you need a very sophisticated building management system, a set of controls to run that and to start to ramp down to your lower levels of cooling, so that, you know, you don't either burn the plants on one cycle or freeze them out on another cycle. A question was asked of what is the cost. 76,000 square foot facility right now, we're at about $10 a square foot, probably $10 to $12 a square foot just for controls. So, you know, the amount of piping, the cooling towers, I wish I had sent some pictures in to give you an idea of the amount of piping. On a project we're doing right now, I think we have 5 miles of fertigation piping. So it's
like pull that up, Art. If you want me to try and pull that up?
What's that?
I think I got pictures with the piping.
Yeah,
hey Sam, while you're looking that up, we got a couple questions from some of the attendees. First one is from Raymond, chapter 26. Is this direct cost only? Does it include insurance, overhead, and profit?
These are burdened costs.
Okay. And the other question is from Stephen at ASP2. So he said, maybe I missed it. What additional GCs are there?
Again, I think the big one is supervision. There is a considerable amount. Yeah, in this room now, this was early on. I'll get back to that question. These are the gas-fired chillers. Those chillers have 7-liter GMC V8s in them that will run 24/7, powering the chiller function for the facility. The piping you see there is the hot and cold water piping and the pumps for them. These are the cooling towers that the pumping is feeding. Each of those is about 40 feet long. This is the electrical switch gear, ATS, other equipment, main service gear. Another shot of the cooling towers. So this is a good shot of one of the grow rooms before the tables are in. If you look at the top, you'll see duct socks, which are flexible duct that deliver the air. These are the dual tier movable veg racks. You got some good photos there.
Thank you, man.
Okay. You know, general conditions, we spent a lot of money on drawings because they kept changing the design. That seems to be typical in this business. You know, again, probably the biggest thing is supervision and project management. We did have additional costs in some of these projects because of COVID-19. Luckily, we got on it early, back at the end of February and early March, and brought a lot of PPE in and hand wash stations before they were all gone. You know, we had a significant on-site office trailer facility. We had additional security. There were quite a few things that went into the general conditions that drove the cost up. Coffee.
Thanks, Art. We got a couple more questions came in really quickly. This one's from Jeff at 26. Are these costs based upon a new facility or one that goes into an existing facility?
Most of these were some type of renovation. And I have to tell you that the national averages, I mean, if you Google cannabis facility, you'll see anything from $50 a square foot to $500 a square foot. I would say that the construction costs alone are, you know, a good ballpark figure is $300 a square foot. And if you're renovating a facility, you're going to spend some of the money that you saved on site work of a greenfield to renovate that facility. We have one right now where we have $1 million worth of structural work on a 2-story, 38,000 square foot footprint building. We have to raise the roof in one area and then support all of the gas fire or all of the electric fired chillers and a monstrous emergency generator on the roof.
So, Art, can I jump in here real quick on this?
Absolutely.
So, one of the things you have to understand, again, that there are so many options in the way that you can grow. And so looking, you know, at an average here, which would be a good renovation cost, mainly for like a single tier flower room utilizing probably HPS lighting. One of the things that you can start to look at is just mechanical and electrical. If you took that cultivation and you went to dual tier on your flower rooms, your mechanical costs would increase by about 70%. And because you're going from HPS lighting, which is $100 a fixture and covers 25 square feet, to LED lighting, which averages about $1,000 a fixture and covers 16 square feet, that number is drastically going to increase as well. So these numbers and the numbers in terms of cost of this facility basically vary greatly by the cultivation methodology and how they're going to grow, what's being implemented in the building. Even if you stay single tier and go to LED to get a more lower cost of operation on your facility, your electric is going to go up, while with LED, your mechanical costs may come down. And to give you an idea why that cost goes so high, in terms of what Art was talking about the system's ability to dehumidify in the space, if you think of a 2,000 square foot home, you've got maybe 5 tons on your HVAC unit. On a 2,000 square foot cultivation room, you've got 60 tons that are going to go into that same 2,000 square feet.
Let me, just to make a point about these numbers, don't write these down to use, guys, because you'll get in big trouble. Mm-hmm. The range, I don't know if Sam mentioned this, but it all depends upon the grower. Things can change so much. And this was more to show how dramatic the cost differences between a lot of what you may be estimating right now and what a cannabis facility cost. So that when you start to see bids coming in and you're looking at these numbers, don't think that this guy, this is the last job and he was ready to retire, so he tried to hit a home run. There's a lot of work, a lot of expense. I've taken people for walks through these facilities, and the comment that I often get is, I had no idea. I mean, if you do heavy pharma and process, then you're probably a bit more familiar with what's being built there.
I got to say, this is impressive. This is impressive facilities, Art and Sam. We got a couple more questions. One that came in, two actually similar. Where are the costs for the racks and the growing equipment in this work breakdown, or is it separate?
This does not include racks, all of the equipment that the employees will need, all of the gowning, all of the interior, all of the consumables, and it doesn't include lighting. For some reason, growers always want to buy their own lighting. And so typically they will buy the lighting, and then the electrician will coordinate with the lighting supplier.
Okay. This other question came in from Henry, chapter 2. What is the organizational chart for the design team, and who is the designer leader? Is it the architect firm followed by the civil structure MEP? And do you have an agricultural engineer in the team?
It should be the contractor, but.
I would say that the question about the agricultural engineer is a great question. I think that when a grower is not on board, I would say that having an agricultural engineer is a very good thing for an organization to ensure that the team has. I think that, from our end of things, 2WR, MJ12, our company, we've been in this business long enough that we understand the cultivation methodologies, and we basically act as a agricultural engineer for our clients. We have a number of clients that do not have growers on board, and we can fully work with them to describe the different ways of growing and what's going to be most conducive to help them achieve their goals as an organization. I'll tell you that our organization is one that when I opened my business, I grew up on the contractor side of the fence. I wore a tool belt most of my young life. So my firm is built around an environment where teaming is the most conducive way to accomplish jobs. We love CM at risk. We love design build type relationships. And so we're a firm believer that building a team involving a contractor at the get-go is the best way to achieve the goals.
That's awesome.
We're proponents of design build and a team approach, and it's been a pleasure working with Sam on these projects because we can sit down, and particularly when you're digging into an existing structure, we can bring value from a field perspective that, you know, is often a big money saving asset to the project. Let's face it, it always works better to have everybody on the same page.
Absolutely.
So a couple more questions. Just wanted to just do a time check in terms of your presentation. Do you guys have a few more slides, or should we slide into some Q&A? We can go either way.
There you go. That's the last slide.
Nice segue. Awesome. Okay. Well, great presentation, guys. And I'd love to, if you guys are good, we can start opening it up for questions. If you have a question, please type it into the chat, and I'll start asking them from the top down. And guys, we'll try to keep the answers as concise as possible, just for the sake of time. All right. We got a question from Brian here. Are the control pricing included in the electrical square foot at $50?
On this one, it is.
Okay. Is there a ROM cost for the lighting?
That goes back to methodology. I mean, right now,
right.
Quick math, I would say that the lighting is probably somewhere in the neighborhood of $14 a square foot.
And again, it's very methodology specific. So if you're growing HPS, it's going to be about $4 a square foot. If you're growing single tier LED, it's going to be about 62 a square foot. As soon as you go to dual, you're doubling that, 125 a square foot.
For electric or for total electric?
No, just for the light fixture itself.
You think you'll be that? Well, see, and you're probably talking canopy square feet, and I was talking
Correct.
Overall square foot, right? Okay, and that's the thing, you know, on a 76,000 square foot facility, you might have, I don't know, what do we got there, Sam? 40,000 square feet of canopy.
Yeah, that's about right.
And you know, the lighting cost. So yeah, you're starting to get up there in lighting cost.
Yeah,
you're
because that facility, shoot, it's that thing's 100% LED.
Yeah. And some of these LED fixtures, the sky's the limit on the price, and they're all computer controlled, and it's pretty sophisticated stuff.
Yeah, so it sounds like the price can vary pretty wildly depending on what you're going to grow and how you're growing. The next one's really a statement. Basically, the statement is that fire protection seems low, especially in New Jersey. The explosion-proof room and multiple levels of plant drive up the cost.
That did not include extraction or the, I mean, there were a couple of heads in the room, but it did not get into any specialized equipment for extraction. That price, you know, that price included a custom-made square fire tank. So that's where we were.
Okay. This question is for Sam. Oh, do you want to take it?
Well, I was going to say one thing on the sprinklers too. We have actually, sprinklers are an interesting animal in these things. So depending on jurisdiction, where we've had multi-tier in veg or in flower, we've actually had fire marshals that want the sprinklers in between every level of benching. And then we've had other jurisdictions where they've allowed it to just be at the ceiling level. And so, you know, the local jurisdiction can also have a pretty hefty impact on the sprinkler cost.
The project we're doing right now was originally designed with sprinklers. And at one point, the building subcode official came in and told us we don't need them because of the code. Sam, I don't think I could possibly go through that again without my head exploding.
Yeah, it's the occupancy classification of a U type occupancy, unlimited area.
Limited area, right. And we ended up going back and forth, and eventually, because of some other changes, we ended up back with sprinklers. There are no rack sprinklers. There's no ESFR. These are pretty straightforward sprinklers. There is a diesel fire pump and the previously mentioned custom fire tank. I think we have 35,000 gallons in that fire tank.
Right, and I think that goes back to the again, dealing with jurisdictions. In this case, it was the state of New Jersey. So the state of New Jersey classified everything cannabis as U occupancy. In the 2018 New Jersey Building Code, they removed the U occupancy. So while they classify everything as U occupancy that's cannabis, they have no U occupancy in the building code anymore. So then it had to go to the next closest, which was a S2, I believe, is what we went to.
I saw a question come up on height of buildings, and that again is one of these questions that comes up based on the methodology of grow. I would, most facilities I think are typically in the 16 to 18 foot clear. And what that allows you to do is to allow some of the heat from the lights to stay up near the ceiling, and you get a buffer zone between the lighting and the plants themselves. Again, when you're building an existing facility, we converted an existing greenhouse into an indoor grow facility and built rooms out of insulated metal panels, which is the typical construction for grow rooms. And we were limited on height. We were extremely limited on height. And I think we have 11-foot ceilings in the facility.
And I just say again that it goes back to cultivation methodology. If they're doing single tier, dual tier, and what size plants they want to grow, what type of lighting they're using. Yeah, all impacts it.
I see Jeff asked about pre-engineered metal buildings for these. Jeff, you know that I think that's the best way to go. Full disclosure, I'm a Butler builder. We did the Butler building for the New York Giants. You can really use any type of structure. If a metal building is designed properly, it can be used for anything. And they do lend themselves to composite walls and composite insulated roofs. So it really doesn't matter whether it's a conventional or pre-engineered metal building. I would caution you about what you're going to do on the roof. If you're going to have a lot of equipment up there, whether you have a standing seam metal roof or some type of membrane roof, you've got to take into account foot traffic. The equipment, there's a lot of equipment in these buildings, and you're going to be maintaining it constantly. Jeff asked about rust problems due to humidity. That's with any building. We used a lot of hot dip galvanized in anything that we put in the building. But remember, the typical way to build a lot of these buildings is not to build rooms. You don't build a big building and grow in it. You build a structure and then you build insulated metal panel rooms within that. Because each of these rooms potentially has a different environment. The different strains of cannabis react differently to different humidity and temperature levels. So you can have two rooms side by side running different parameters for grow at the same time.
Great work, guys. We have a couple more. Let's see if there's any. Do you guys see the chat? The chats in there. See if you want to pick off any of those.
I don't right now. If you want to read them off, we'll try to tackle them.
All right. Let's. Okay, this one's for Sam. Sam, have you been involved in the nursery type cannabis outside facilities as well?
And say that again.
Outside facilities.
Oh, and outdoor. We've done indoor. We've done greenhouse. We have a client in Oklahoma who does outdoor grow. So all of that product has to be fully extracted. They can't sell the flower. Yes, and we've done here in the United States. We've also done designed in New Zealand, Gibraltar, and currently have a facility under construction in Macedonia.
Wow, going international. What's the average size of a facility?
Great question. You know, I think that right now, what we see pretty typical is it really depends on the size of the organization. So a lot of the multi-state operators we're working with are, if they're doing warehouse, it's probably somewhere in the 60 to 100,000 square foot range. If it's greenhouse, we've seen, you know, we're working on currently 270,000 square feet of greenhouse. We've done greenhouse designs upward of 800 to 900,000 square feet.
Wow. You didn't tell me about that one.
That was Massachusetts. You know, it really depends on the organization. You know, when you're dealing with smaller kind of mom and pop shops, or it's going to be a one-off, they may be more in the 30, you know, kind of 20 to 30,000 square feet. Then it kind of ranges by states too. So like Illinois did the micro grow, which was a diversity kind of plan. And basically under that license, it's about, I think, 10,000 square feet of canopy, which gives about a 20 to 24,000 square foot building if they've got extraction and infusion, a vertical facility. So, you know, part of it depends on license tiers. Massachusetts, for example, you can get a license from tier 1 to tier 10, which means your cultivation canopy is anywhere between 5,000 square feet up to 100,000.
I think that, you know, when you put it into perspective, if you're spending $300 a square foot on a facility, you're buying property, and then you're outfitting it, while you're in construction, you already have a considerable investment in staff. So your burn is considerable before you even open the doors. If you're building a 50,000 square foot facility, you're going to probably be north of $20 million pretty quickly.
Wow. Follow-up question on that is, how many projects have you guys done in New Jersey, and where are they located?
We've done 4 right now. We did an initial construction of a containerized grow system where we converted an agricultural building and moved in effect, a shipping container, an overseas shipping container in, and brought that online. We then brought on a 40,000 square foot greenhouse grow. It's the first greenhouse grow in the state of New Jersey. We're finishing a 76,000 square foot grow facility that has already come online for phase 1. Phase 2 should be completely wrapped up by the end of the year and operational. And then we're trying to get a CO right now on a dispensary.
Wow.
And we're working together on another site that is starting out with the shipping containers, and then will be the second phase as about a 50,000 square foot cultivation, fully vertically integrated facility.
That's actually total 76,000 under roof. That's the two-story, yeah. And there's a dispensary project with that, and also a second phase of containerized grow facilities. We've seen quite an interest in licensees buying these shipping containers that have been converted into grow facilities, and it's a nightmare. These people are out there building them. They are not UL approved. They arrive on the site and the building inspector just laughs at you. So if you get involved in those, run far and run fast.
Awesome, guys. Well, I think that concludes our questions. I'd like to bring Bob back here into the spotlight here and kind of drive us home. Let me add him in. There you go. Hey,
just
Bob,
one thing
you're on. Can you unmute yourself?
One thing I'd like to say is that Bob has been very deeply involved in one of the projects that we're working on, and has really been an asset to that project, and probably knows these numbers better than anybody.
I want to thank both Sam and Art for taking the time. I know that you guys are very busy, and to educate everybody here, we had about 55, 56 people attend tonight.
Right.
And it was a great talk. It was probably one of the better presentations that we had in a while. And, thank you very much for your time and effort. Really appreciate it.
We appreciate the opportunity.
Yeah, on behalf of ASPE National, also ASPE Golden Gate here in San Francisco, and ASPE 26 in the Garden State, man, we really appreciate it. Great presentation. You guys, the energy, the knowledge, the transparency, unparalleled. Thank you.
Thank you very much.
Thanks
appreciate the opportunity to give the presentation, and nice meeting you guys.
All right.
I'm sure we're gonna reach out to you again, because for maybe a national conference or something like that. The knowledge you guys are providing is amazing.
Thank you.
Somebody asked if you can share your background pics.
Absolutely.
I just want the free samples.
Hey, one thing.
I don't like it either.
Bob, if you give me email addresses for folks and names, we've got a little certificate that says you basically participated in 1 hour seminar on cannabis, and we'll get that certificate to you.
All right, that'd be great. We'll take care of that before the end of the week, for sure.
All right.
Yep. Thank you. This was a 90-minute seminar, actually. So believe it or not.
Hey, Sam, I just want your email and be able to pick your brain from now on.
Absolutely. Bob's got it.
Thank you.
Thank you.
All right, folks. Thank you. Good night.
Thank you,
guys.
Thank you, Bob. Thank you,
Thanks.
guys. Thank you, Gustav.
Thank you.
Thank you, Gustav. Appreciate it.
Thank you.
My pleasure, guys. Take care.
Hey, good presentation.
Hey, Bob,